Hi friends, in this video, we will talk about third strategy in prompt engineering, breaking down complex tasks into simple subtasks. Let us review a conversation between the user and a simple chatbot I created. I need to schedule an appointment for my health checkup. Chatbot responded, to assist you with scheduling a health checkup appointment, can you provide me the full name, the address, the date of birth and the phone number? I provided that details. It's thank you me and asking, can you please provide the health insurance details? And asking for, do you have any health concerns? I responded that also. Now it responded, do you have any medical records? And finally, it concluded instructing me to come little bit early. This looks like a real conversation between two people. Please note that I'm running this example on OpenAI Playground. This is going to be very interesting. The tactic we are going to use today is called use intent classification to identify the most relevant instruction for a user query. What is that? When we develop a complicated software, we usually break it down into smaller, more manageable modules, right? This decomposition simplifies the overall program's complexity. Similarly, when we want to write a prompt for a complex task, it is beneficial to divide it into several smaller, more manageable subtasks. This approach helps the model to understand your text clearly and that minimize the errors and improve the quality of model's response. The key is to organize tasks into pieces that are well-defined and self-contained. While writing the prompt in my example, I did two steps. One, classify the user request. Second, instructs the model how to respond based on the classification. Let us review that. The first thing I did here was split the possible reasons for the user's request into three primary categories. One, a call from new patient. Second, request from an existing patient. And third, an immediate appointment. There can be many more categories, but for simplicity, I considered only these three categories. I then split each category into subtasks. A new patient can call for a general health checkup or seeking a primary care physician. So I added those two subcategories under new patient. I also subcategorized other two primary categories as well. You can see that here, the existing patient subcategories and the subcategories for the urgent care. So let us review my prompt. I started the prompt with classify user request into primary category and secondary category. After that, I provided three primary categories and below that, I split each primary category into subcategory like new patient, existing patient, and the urgent care. Addition to the classification, I requested the model to provide the output in JSON format. So let us test the classification part first. The query is, I'm new to this area looking for a primary care doctor. Do you have any availability for new patients? See the response from the model. It classified the request into primary and secondary. The primary is new patient and secondary is seeking for primary care physician. So the model analyzed the query and it was able to classify it as a new patient request and looking for a primary care physician. That is smart. The next query is, I need to schedule a follow-up appointment for Dr. Smith to discuss my lab results. And see the response. It classified the primary category as existing patient and the secondary as follow-up appointment. That is also correct. Let us test two more queries to see if it is working correctly. I sprained my ankle and I think might need an X-ray. And it classified that is an urgent request from a user and classified the primary category as urgent care and secondary as minor injury, sprain or cut. Let's try one more. My child has a high fever and our regular pediatrician's office is closed. Can they be seen here? And the response is, it is also classified as urgent care and the secondary is sudden illness. So based on my prompt, the model was successfully able to classify all the user requests. Let us go one more step further to instruct the model what it should do when the request is from a new patient for a general health checkup. Remember, we have two subcategories under new patient: general health checkup and seeking a primary care physician. In my example, we are going to instruct the model to handle only requests for general health checkup. Chatting is an iterative process, a back and forth exchange between the user and the chatbot. Based on the user response, I can check the type of user request in the application code and send only the prompt that is relevant to that user request. In the sample prompt, I want the model to handle only the request to handle the subcategory, a call from a new patient for a general health checkup. This way, I don't need to worry about writing and sending a large complex prompt to handle all the possible patient request scenarios. Earlier, I mentioned that focusing the model to handle one subtask would enhance model's response quality and also help to save some money. Saving money? Yes. When you send a request to OpenAI API, they charge you based on the length of the prompt and the model's response. So you need to be mindful of the length of the request and the response. Now let us review the prompt to handle both steps: classify the user request and instruct the model how to respond based on the first classification. In the prompt, my context is you are an assistant responsible for scheduling doctor's appointment, and you will receive patient's request for scheduling the appointment. The next part in my prompt is for scheduling new patient's health checkup appointment, and it says if the user request is for primary category new patient and the secondary category general health checkup, then help the user to schedule an appointment, and you need to follow the following steps. And it says ask the full name, the date of birth and the details, ask for the health insurance details, ask for the health concerns, and finally it says ask the user to arrive 10 minutes early to fill the paperwork. The next part of the prompt is asking how to send the output. We reviewed some part of this earlier. It says after chatting with the user, classify the user request into primary and secondary category. It says produce the JSON format with the keys primary, secondary and the patient details. So we want to add the collected patient details as part of the JSON. And see the next part in the prompt. It says if the request does not fall into the primary category, new patient for general health checkup, then identify the appropriate category and produce the information in JSON, including primary and secondary key. So what are we instructing here is you handle the user request if it is for general health checkup, but otherwise, you just produce the JSON with the categories because we do not have the prompt for handling the other categories. And after that, I give the section to classify the user request, which we reviewed earlier. Now we have the prompt to handle both steps in the scheduling. Let us test it. I need to schedule a follow-up appointment for Dr. Smith to discuss my lab results. It responded primary existing patient and secondary follow-up appointment. That is working fine because we did not instruct the model to handle this existing patient category. Let us try another one. I sprained my ankle and I think it might need an X-ray. And what did it come up with? It says primary category, urgent care, and secondary is the minor injury. That is the same thing. It just classified the request as an urgent care classification. But when I say I need to schedule an appointment for a health checkup, it responded to assist you with the scheduling a health checkup appointment. I need more information from you. So I provided my details and now it's asking for additional details like existing medication, allergies, and the required information for scheduling a new patient. And finally, it concluded. Please remember to arrive 15 minutes early to fill up the paperwork. It also provided the collected information in the JSON format, which your program can use to notify the scheduling person or schedule in the appointment system. That was awesome. So here we saw two steps, right? Classifying the user request and responding to the user if the request is for a new patient appointment. Currently, I write the special prompt only for the general health checkup. To make this a full system, I need to write prompt for each primary and secondary combination. Once we have all the prompts working, then we need to architect the code and use each prompt according to the user request. Remember, you will never get this working on your first try. I went through many iterations to make it work and get consistent answers. So don't expect any magic. One thing I realized that every word and every special character in your prompt contributes something to the model's response. That's all for this video. I hope you liked it. In the next video, we will go over the next strategy in prompt engineering. Goodbye.